This afternoon I gave a talk at the International Probiotic Conference on the importance of mechanisms of action in probiotic development, in the probiotic development journey. And I stressed out the limitations in the most traditional ways of developing probiotics, starting from the isolation of bacteria from foods, from healthy infant species, for example, from different origins, and from there they went to the lab to see what bacteria could be cultured, and downstream what benefits they could bring. Or there's a second new traditional way of development that is comparing populations, the microbiome from populations that are healthy or diseased, to see if there are markers that appear of protection, correlations between disease or healthy states. And showing also the limitations of this approach, the lack of causality, and the limitations in terms of the safety of the bacteria that could be selected. So in the first case, you limit the choice of microorganisms because not everything can grow in the lab, especially in presence of oxygen. So basically we can estimate that there's only 1% of the bacteria that could grow in the lab, so we lose 99% of the other ones that could bring a lot of benefits. In the second case, when you compare the microbiome, you have a broader base of selection for the microbes, but then you get a lot of signals of microbes that don't have a history of safe use. So regulatory-wise, it's more complicated to bring to the market. So we have an example of success with Akkermansia, but it's just one. It was a long story to develop the novel food file, and it's only approved as a postbiotic, not a probiotic. So these are limitations in bringing innovation to the market of probiotics, and we bring to the table a new way of developing probiotics from the bottom-up approach, from the mechanism of action, from the target-based cellular or molecular target that you want to activate in the host, and based on a lot of screening DNA databases that we now have on microbes. Having this target enables a new way of selecting from the target and then demonstrating that it works in mice models and in the host. So it opens up to more potential bacteria, but also starting from the mechanism of action, you get better reproducibility in your outcomes, and you get better potential for the optimization of processes to make sure that your active molecule is going to be present in your process, that you can standardize on that, and you can have quality control points on such actives. Yes, well, if we speak about probiotics, the intended use is usually in the healthy population, but more targeted for sure, and it opens the door to concepts of precision probiotics, and we are considered as the pioneer of precision probiotics. Yes.